So now you know what the data collection software will facilitate. You know what kind of data we want to collect and track. Let's see how to design the app. We'll talk about two basic concepts we are going to use to describe what we want to do with the app and which data we want to track with it. Those concepts are data model and use cases. Let's first talk shortly about what is a data model. Let's make it very simple and say that data model is actually a structure that holds actual data. In data modeling, we design concepts and data, its properties, relationships between those, constraints for working with data. For example, if you want to collect information about mobile researchers, we could identify a concept of researcher where this concept is described by its properties, such as first name, last name, email, career stage, gender, and other information. There could be other concepts, such as research project, described by the properties like title, begin date, duration, budget, and the others. The concepts of researcher and research project must be somehow related, because research projects cannot exist without the researchers working on them. There could be also constraints, such as only one researcher can be a principal investigator for one project. Another constraint may be defined to restrict the maximum number of projects on which researchers can be engaged. Finally, a restriction is when you say there is only a predefined list of options from which you can choose when you want to describe an assistance you make, a list consisting of fixed number of items such as entry conditions, accommodation, social security, and the others. So the data model would then be the list of all those concepts, their properties, their relationships, their restrictions. That's data model, simple as that. How can you build a data model? Data model is typically used to facilitate a conversation and exchange. You discuss and exchange what you need, what kind of information you need. You discuss about the concepts which I previously introduced. Those concepts arise from the conversations you make about your work. You say that you want to track and store data about each service you make. Hey, service is a concept. It stands out, we talk a lot about it. Service is a concept for which we would like to design the properties. Services are delivered to international researchers or administrative staff from other fields. Okay, so there is a target group. So this could be a property of service concept. And the possible values of this property could be international researcher or administrative staff. You cannot choose musicians as a target group, only those from the predefined list. Any service can be characterized by the time of delivery, way of delivery, type of service. Here are more properties. So time of delivery is a property. Way of delivery is a property. Remember the signposting, personalized assistance, and short inquiry. The type of service may be any of or more of the categories, some of entry conditions, diploma recognition, social security, and others. Basically, you exchange, you discuss about what data you need, and then pop, it appears that there are some words that become commonly used concepts. Some of them you mark as properties of other concepts. Service has properties. Properties are the target group, time of delivery, way of delivery. For some of the properties, you find out there are some predefined choices. So if you imagine the form for data collection, the values of those properties are not freely entered. You can choose between some choices. Which some choices? In the example of the slide, the options are entry conditions, diploma recognition, social security, and health. What needs to be done by this application in the future, which we are going to use for data collection? Try to identify all actions that you do with the app that have certain outcome and that is typically carried out on one app page. We call those use cases. For example, we need to be able to register administrative staff. The outcome is created user account. It is done on a single page with the registration form Save button. Once you click on this button, the action is carried out. The second use case, one that precedes many others, is logging in. You do the task on a login page by entering username and password and by clicking on a login button. Then, after successful login, you are forwarded to a main app page from where you can access other functionalities. That's an outcome. You're capable to access the app functions. Once we create a list of use cases, we can try to list them and maybe classify them into categories for different reasons. One reason may be to hide some of the rarely used functionalities by classifying those into a group of advanced actions. You can see at the slide that program registration and even administrative staff registration is not something that is being done often. On contrary, new researchers are registered daily, new services are added sometimes even on hourly basis. Another reason for classifying the use cases into categories may be to try to allocate specific functions to the specific roles. For example, some reports are accessible only by the service center managers, some others only by the university managers. At the beginning of this presentation, I mentioned one term, conceptualization. Conceptualization is indeed the process in which we design the data model, namely, identify some concepts, their properties, relationships between them. Have a look at one data model that could be universal to all needs of the digital service centers. We have already identified researcher and service as concepts. We have already said that there must exist some relationship between them, and this is also reflected on this scheme. There is directed line from researchers to service. Why this exact direction? To answer this, we need to explain the concept of cardinality. In a database, cardinality usually represents the relationship between the data in two different tables by highlighting how many times a specific entity occurs in comparison to another. Let's say that each of the concepts on the scheme above is a table. Let me tell you a secret, it will become one eventually. Table stores data in rows. For example, a table with researchers will probably store data, so all data about one specific researcher will be in one row. We know that there are some relations between data about researchers and data about services. Let's try to formally describe it by using the concept of cardinality. Ask yourself cardinality questions about two concepts in both directions. First, for one researcher, how many services there are in the table with service? Obviously many, because one researcher can ask multiple questions. Let's see how it works in opposite direction. For one service, how many researchers there are in the table with researcher? We can ask it in a different way. How many researchers can ask for one registered service? Do you remember what we defined as a service? Assistance provided to one researcher. So the answer is one researcher. Let's now see what we have on each of the sides. On the side of researcher, we have one and one. On the side of service, we have one and many. Now we do the superposition. Each of those two elements we transpose to one by following two simple rules. One and one gives one, and one and many gives many. So we have one on the side of researcher and many on